Hello, ladies and gentlemen. We have a couple of really important new words to talk about today because we're going to do the section on secants and tangents. Secants and tangents are lines, and they're lines that go through a circle in particular ways. So a secant is a line that intersects a circle at exactly 2 points. So if I draw a line and it kind of goes into the circle and then it goes out of a circle, I've drawn a secant. All right, so it's a line that intersects a circle at exactly 2 points. And you might notice already that it creates a chord. There's a chord in there from this point on the circle to the other point on the circle. Every secant contains a chord. So every secant contains a chord. Okay, so that's one important thing about secants. Tangents are a different kind of line. Okay? Tangents are lines that intersect the circle at exactly 1 point. So a line that intersects a circle at exactly 1 point. And you might be asking yourself, well, what does that look like? So tangents can be a little bit tricky to draw because they're mostly outside of the circle and they just touch it once. So usually what I do is I draw a point on that circle and I kind of eyeball a way that there would be a line that goes and it touches that circle one time and it starts going back away from the circle. So I kind of sketch it out first. So that line is a tangent line that touches the circle exactly once. Okay? And the way that we make sure that we have a tangent line, because it really can only have this one angle here, is the tangent line is perpendicular to a radius drawn at its point of tangency. So that is where the tangent line intersects the circle. So if I go perpendicular to this tangent line and I make that radius there, that is going to be where the tangent line is. So it's perpendicular to a radius drawn at its point of tangency. So we can't make this line go tilted in or tilted out, because if we did, it would run into the circle more than one time. It needs to only hit the circle once. All right, so let's talk about the segments that we can make with tangents and secants. So a tangent segment has its endpoint on a tangent line. So if I put a point right here, and I think about that a tangent line would go outside the circle, I'm just going to take part of that tangent line, and I'm going to say, here's the tangent segment. It touches the circle at one spot, and if I were to extend my tangent line, it keeps going away from the circle. So a tangent segment is, and this has a particular definition, it's the part of a tangent line, so it's part of a tangent line between the point of contact and a point outside the circle. And a point outside the circle. Okay? So the tangent line starts on the circle and it goes out. A secant segment starts outside the circle and it goes in and across. So if my secant spot is out here, it's then going to run into the circle and it's going to stop on the opposite edge of the circle. So it's not going to go all the way through. Okay? If it's a secant segment, it runs through the circle and then it goes outside of it a little bit. So the secant segment is the part of a secant line, the part of a secant line that joins a point outside the circle, a point outside the circle to a point further inside the circle. So to a point further inside the circle. All right, and one thing that's important to say about a secant segment is that one of its endpoints has to be the edge of a circle. So it goes from the edge of a circle through the circle and out the other side. All right, so here's some theorems. These are going to be theorems about angles and lines and tangents. So if two tangent segments are drawn to a circle from an outside point, then those tangents are congruent. And I'll show you what that looks like. So if we have an outside point here, maybe there's a point right here, and we're going to draw two lines that are tangent to our circle, we're going to be really careful and we're going to kind of think in our minds where that line is going to end up if it can only hit the circle at one spot because it's a tangent line. So there's a tangent line, not a very good one, but there's a tangent line. And then I'm going to draw another tangent line going the opposite direction. So I'm going to take this and I'm going to say, well, there could be another tangent line. One good way to do this is to think about if I was to draw a point on my circle and connect these two. That could be a way to do it. So there's another tangent line. So there's two tangent lines of my circle. And the place where they start and the place that they touch the circle, the point of contact, the segment that's created is a congruent segment, okay? Not this whole line where it keeps going, but the tangent segment from the point outside to the circle to the point on the circle is the same in here and it's the same in here. So tangent circles, if we have two circles that are tangent to each other, tangent circles are tangent if they intersect at exactly one point. So if we talk about circles that are externally tangent, there's a circle that touches the outside of another circle like that. If we talk about points that are internally tangent, if we have one circle, we can have another one, and if you think about like a marble rolling around on the inside of a beach ball, it only touches at one point, but it could be in there and it could be internally tangent. So here we're going to use tangents and secants to find values. So we've got some information. We know the radius of the circle is 7. We know the tangent segment ZY is 24. And we want to find XY. And one thing to remember here, the key point, is that if we have a tangent segment and a radius, they're always perpendicular. All right, that was part of our definition. A tangent line is perpendicular to a radius drawn at its point of tangency. So we have a right triangle here. We have a 7, 24 blank right triangle, and we know that that's a Pythagorean triple with 25. So it's a 7, 24, 25 right triangle, which means that XY is 25. All right, here's some other things. We have AB equals 2x minus 1. And we have BC, which is x plus 3. And it wants us to find the length of AB. So remember our theorem about having two tangent segments drawn from the same point. So from point B, we've got two tangent segments. So they must be congruent. So we can say that 2x minus 1 equals x plus 3. And we can just solve that equation, right? So we will add 1 to both sides. 2x equals x plus 4. Subtract x from both sides. So x equals 4. Right? And since we want to find the length of AB, we're going to plug 4 in for AB. So 2 times 4 minus 1 is going to be 7. So AB would equal 7. Now, one thing to keep in mind here, not really keep in mind, but remember that you could extend your thinking if you wanted to. So we could keep going with this problem. We could draw a line BD, and we could find the length of that line, because what we know is we know that AD and AB are perpendicular, and we could think about that as well. So think about the different shapes that you make with these lines because of the perpendicular angles that we know are going to be there. All right, some places might need that idea, especially in your homework problems or problems on quizzes or tests. The next one here is pretty simple. It says find the measure of angle ACD. This is a problem that just is kind of like the stuff that we were doing yesterday. So if our arc AB is 50 degrees, we know that the central angle is also 50 degrees. And because this is 50 degrees and DB is a diameter, okay, we know C is in the center, so DB is the diameter, which means that together we have 180 here. So we've got 130 degrees for for angle ACD, which also means that if we wanted to find arc ACD, that would be 130 degrees as well. So nothing fancy there, just a couple of angles that you may want to remember. All right, and then finally we've got a concentric circle example. And this one is important because it is in your homework. So concentric circles with radii 8 and 10 have center P. XY is tangent to the inner circle and is a chord, so it's tangent to the inner circle, it touches the inner circle once, and is a chord of the outer circle. It touches both sides of the outer circle. We want to find the length of XY. The radii here are going to be what does it for us. So if we have the smaller circle having a radius of 8, PZ is a radius of the smaller circle. So we can say that PZ is 8. The larger circle has a radius of 10. Now, P out to here, out to this edge is 10, but that's not a helpful measurement for us. However, we can draw the radius of the larger circle right here from P to X. There is a length of 10. And since we know that a tangent segment is going to be perpendicular to the radius of a circle, then we know that this is a right angle. So we just have a blank 8, 10 right triangle, right? And we know that that must be a 6, 8, 10 right triangle because we know Pythagorean triples. But remember, that's not the answer. We want to find xy, right? So we need to take 6 and we need to multiply it by 2 because we have a chord which is cut by a perpendicular bisector. So these two are the same. So 6 times 2 gives us 12 is equal to segment xy. All right. Go ahead and try the problems in your homework that are related to this. Some of them might be a little bit of a challenge, but that is a good thing. If you've got any questions, please don't hesitate to ask. All right, thanks so much. See what you can do with this worksheet.